Hello everyone and welcome in this new video tutorial of AnimalTA. Today we will see how to analyze the trajectories we obtained with the program. In this tutorial I will consider that you already know how to prepare your videos, prepare the tracking, run the tracking and do the corrections of the trajectories. If you have some problems with one of these steps, I invite you to go to check the other videos from this channel. Today we will work with 5 different videos. The first one will be a spider in an open field. Then we will have 2 fish in a social choice test, a vacuum robot moving in a kitchen, some ants, and 2 sheep in a fence. So I will begin with the spider research. So first thing we need to do will be to go to the prepare analysis panel. When you arrive in the analysis panel, you will have, like always, your video that's displayed here. You can move with the timeline and you see this time again the trajectories of the target. Like before, you can change the length of the trajectories to make things easier for you. And you have a bunch of options. Perspective correction, I will discuss that a bit later. Then apply a smoothing filter. So I will zoom in a little bit so you can see better the trajectory. As you can see, the tracking is not very fluid. There is a lot of noise all through the trajectory, and this is usually due to the imperfection of the tracking or of the video recording. To fix this problem, we will use the smooth trajectories option. As you can see, the moment I press it, my trajectories are smoothed. Of course, the parameters of the smoothing can be changed. So if you want to change the parameter, you have here this P button. When I press my P button, I'm here and I can set different lengths of the windows of the smoothing, which is how much frame we take before and after the current frame to smooth its actual value. So if I put a very high value, you will see that my tracking is very far from the real position of the spiders. The perfect value for the smoothing is very variable. It will change according to your model species, to your frame rate, to the quality of your recording. So I cannot give you an universal value. And I advise you to try different values. You have a direct preview of the effect of these parameters. And I also invite you to go to have a look in the guideline of the program if you want to have more information or to make some research about the Savitsky-Golay filter. So it's everything is written either here in the information panel or in the guideline of the program. So this is for smoothing. Once you apply the smoothing, it will be kept for all the other analyses. You can also use this apply smoothing to other videos if you have a high number of video and you want to apply the same smoothing to all of them, which is what you should do if you are, for instance, working with different replicates from the same experiment. You want to use the same smoothing parameters for all of them. Then let's continue to the analyses. And we have 4 kind of analyses here. The first is the analysis of individual trajectories. So here, if you change from one kind of analysis to the other, you can see that you always have only one that's selected. Don't worry, it doesn't mean that the program won't make the other. The program will always make the 4 kind of analyses. The only thing that when you select one of them, you will see in the video the effect that you selected. So for instance, when I select my analysis of individual trajectories, what I can see here is the movement speed of my target. So the movement speed at this precise moment. And you can see that the speed is either highlighted in green, like here, or in red, like in this moment. When the speed is highlighted in green, it means that the program considers that the target is moving. When the speed is highlighted in red, it means that the program considers the target is stopped. By default, the program considers that a stopped target is a target with a value of speed of 0. But you have to consider that there is always, like I said before, some imprecision, and you almost never have a real speed value of 0, even if your individual is not moving. For instance, right now, if you look at the spider, she's not moving, but still she has some speed values that are a bit higher than 0. So you can change this threshold. So you press your parameter button here, and you will have a graphics that appear that will show you the speed of the individual as a function of time. And you have here this blue line. When you press somewhere in the graph, you will change the position in the video, and the blue lines is the current frame. And you can also work this way to see what is happening. These red lines here is your movement threshold, which means that for all the frame that the speed of the target is lower than this red line, the program will consider that the individual is not moving. If the speed of the target is higher than this threshold, the program will consider that the individual is moving. So you can use this threshold to determine when you consider that an individual is moving or stopped. Of course, again, it will depend a lot of your species, but even of the aim of your experiment. For instance, I won't put the same value if I'm interested in knowing whether my individual is completely immobile or if my individual is just not making a displacement. For instance, here, if I put my threshold there, I will consider that for all this frame, my spiders is not moving. But if you take a look, you can see that it still have a non-zero value. It has a quite high value in comparison to what is happening here and here. And if you have a look at the video, you will see that it's because my spider is moving, but it's not making a real displacement. She's just making a rotation. So this rotation is a kind of movement, but it's not as fast as a displacement. So if you are interested, for instance, in considering this kind of behavior like a movement, you will decrease your threshold and put it somewhere here. But if you are interested in only real displacement, like the spider moved, maybe you will put it like this. And in that case, this is considered the displacement, but not the rotations. At any moment, you can check whether this threshold seems interesting for you by having a look at the video and whether you would consider whether it's a movement or not. In that case, we only have one target, but if you have more than one target, you can also see this threshold with the other target, pressing this button, and you will have all the possible targets that are displayed here. If you are interested, you can just also put a value, write down the value directly here. So if I want a 2.5 millimeter per second threshold, I will just write this here. In this window, you also get some information about the future results you will get. So for the selected target, you will see the proportion of time this target is lost. So here 0%, so it means that I don't have any value in my table. It gives you also the speed, the average speed of the individual, and the average speed when moving. So the average speed is calculated over all these values that we have here, but the average speed when moving is calculated only over these values that are above the red line. Then it gives you the proportion of time moving and the total distance traveled, and finally the total distance traveled when moving. So once again, the difference between these two is that the total distance traveled take into account what's happening in all this part of the graph, while the total distance traveled while moving is only taking this part of the graph into account. And of course, if I change my distance threshold, you can have a look. I will put a very slow one. You see that I have big changes in all these values. I think that's all for the analysis of individual trajectories, so I will now change the video and take another example to continue. We will now continue with our second video, which is about the fish social choice. I select my video, go to prepare the analysis. In that case, so we again can see the trajectories, But I am a bit less interested in the trajectories themselves. What I'm interested in is to know how much time these two fish spend close to one part or the other part of the arena. So to do that, I will go to the spatial repartition, and in this option, I will be able to add elements of interest. By default, as you can see, there is nothing, but we can add some elements. To add them, you just press the P button here, which open this new panel, and in this panel, you will be able to add some elements. In my case, I'm interested in adding the border here. So I will select border, and I will select this border first. Once I selected the border I'm interested in, so in my case it's only one, but you can select more than one, you then press the return key on your keyboard. You can change the name of this new element, so we will call it part A, because this is the A part of my arena. And it already gives you some information. It tells me that my target was on average at 14.3 centimeter to this border. What I'm interested is in knowing the time this target spent close to this border. So I can define a threshold of distance, and I will tell that I want a 5 centimeter area. So if I write here 5 centimeter, the program will automatically calculate how much time my target spent inside this 5 centimeter area. And it also tells you the latency to approach the border. Well, that's good for my part A. I can repeat the same thing for my part B. So select border. Don't forget, like me, to press the return key and then give it a name, part B. And again, I'm interested in what happened in this 5 centimeter from this border. Well, that's a first kind of element. It's a border, but you can also add other things. You can add points, you can add line, or you can even add areas of various shape that you can draw. In this experiment, it was also interesting in knowing how much time this target changed its position in the arena. So I will also add a line and use the border as guide. So I select one first border, and I will tell to the program where I want my line to be drawn. And I would like my line to separate this arena in 3 different parts. So I will put it at 1/3 of the arena. In that case, I will write directly proportion, but you can also write directly the value in millimeter if you are interested. So as you see, it will put a first point in the position I asked, and I will do the same for my other border. So here again, I'm interested in putting something at 1/3 of my arena, and I have my first segment. As you can see, this segment also gives me some information. So again, I have the average distance of the target to the segment, but also the number of times the target crossed this segment, and the latency before the first cross. So as I told you, I'm interested in doing this process twice because I now want to separate my arena in 3 different parts, here and again here. And that's it, I have my second segment. Once again, you can change the name of the segments. I will call it A and B because it's the place of the arena. And that's it. So this will give you a lot of information also later when we run the analyses for all the videos. But it's a quite time consuming step because you need a lot of time to select everything. What AnimalTA allows you is to do that for only one arena and then to expand all these elements to other arena. So I will press my button here and I can select which element I'm interested in. So in my case, I'm interested in all the elements. And then I will select the arenas in which I want to paste these elements. So in that case, I'm only interested in pasting my elements in this second arena. But you could do it for more arenas. Validate. And now you can see that if I change and go to the other arena, it also did the exact same elements with the same disposition. So this way, if you're working with 200s of videos, you don't need to make all these steps 200 times. You can do it only once and then copy paste all the elements in the other arena. A little tip here is that for this process to work, you need to have arenas with the same shape. So if you try to, for instance, apply this to a circular arena, it won't work. It has to be an arena that's similar, that has the same number of segments, for instance. So even if this rectangle is a bit smaller, is a bit larger, is a bit thinner, it's not very important as long as it's a rectangle. Okay, let's go back to my main window. And now, as you can see, I can see directly the spatial repartition and the elements are drawn here, which indicates me what the program will analyze later. So I have indeed my two arenas and my two segments. And we can check. So just that to confirm, the program told us that this segment was crossed 3 times. So we have here 1, 2, and 3, and the other one twice, so 1 and 2. Okay, so that's all for the spatial repartition. There are some more elements, but I advise you to have a look and try different things. It's all working in the same way. Let's continue. The next one is about the inter-individual distance. So for inter-individual distance, I will change and go to my ends social interaction video. The end social interaction, so it's just a video of 10 ends. As you can see, they are quite fast, so I will decrease a bit the tail length so it's less messy. And what I want to do is to go to inter-individual distance. When you press this button, the only thing that will appear is the cumulative sum of all the distance to connect all the individuals. So this is the total length of each of these segments. But if you press the parameter button, you have access to a new parameter, which is the distance threshold at which you will consider that two individuals are close or in contact. In that case, we call them neighbors. So if two individuals are at less than 3 millimeters from each other, the program will consider them as neighbor. And you can, of course, change this value. The red circle here helps you to see what it means. So if I write a 3 millimeter distance, it means that if another individual is inside this red circle, it means that these two individuals are neighbor. In the case of these ends, I think 3 millimeters is quite good. So you can see first some results that the program is giving you. So on average, for instance, this one at 0.1 neighbor, we can change, maybe take someone that's a bit more, has a bit more neighbor. I don't know if we have, well, this one, for instance, almost never had any neighbor. This one has some, and let's try, okay, just to have an idea of how these values impacted the results. So if I put this time 10 millimeters threshold of distance, in that case, this individual has on average more than one neighbor, which means that it spent a lot of time with conspecific. Proportion of time with at least one neighbor. It's another way to tell a proportion of time not alone. So it's almost 70, almost 80% of the time. And on average, the distance to the nearest neighbor, it's 6.72. Well, of course, this last value is not impacted by the threshold you write here. And well, that's it. Once you did that, it's enough. You will then later get a lot of results according to this data, but they are not visible right now. Like before, you have this apply these parameters to other videos button, which will allow you to not have to repeat the same step for each of your video. You will just press this button here and then select all of your replicates so that they can be analyzed in the same way. And finally, the exploration. Let's go for another video. The vacuum robot is a quite good example of this analysis method. So in this video, we have a little robot that's cleaning a kitchen, and we have, of course, the trajectories of the robot's displacement. and the exploration will tell us how much of this arena the robot did explore. So in that case, we could consider, for instance, that it's a proxy for the cleaned part of the kitchen. So I will go to the exploration, and in this panel, you can choose here an area you will consider that your target is exploring at each moment of the time. So for instance, if I put something very small, so the program will consider that my robot explored only this red path here. Well, obviously, my robot is a bit bigger, so I know that the part of the kitchen that it's cleaning is much bigger than this. It's more something like this, so I have to increase here a bit. Maybe this is not bad because I know that it's not really cleaning what's on the very border. Well, after it's up to you to choose what you think is the best to represent what your targets are exploring as a function of time. Well, in my case, I know that the robot cannot explore higher than its own size, but if you're working with individuals that are able to perceive around them, maybe you can also put something a bit bigger. Well, you see that here, according to the value you select here, you will have the proportion of area that your target visited. So in my case, my robot visited only 80% of my kitchen. It didn't clean everything. So that's a first way to estimate exploration value. But there are two other methods that are proposed by the software, which are more classical, which is by working by mesh. If you choose, for instance, a rectangular mesh, the program will just separate your arena in various cells. So all cells are square, so they are all of same size. And you just have to choose what you think is the best size. So if you want something more precise or more generalistic. You can so select how much surface you want one cell to be. So in that case, each cell represents 3000 centimeters square. If you have circular arenas, you can also do the same with the circular option. In that case, you have another parameter which allows you to change this kind of the shape of these cells. But of course, all the cells are always the same size. Whether it's like this or like this, all the cells are doing the same size. And the program, in the case of the rectangular or circular mesh, will give you the number of cell your target visited. So in that case, for instance, seems that like my target went in 20 cells out of the 21 present, so almost everything. Well, let's go back to our video. So now it will display what the program considered that my target is exploring at this precise moment. And again, you have here the apply the exploration parameters to other videos. So you don't need to repeat this process each time. You just press this button and select all your videos once you have the good parameters. Okay. So now there is a last thing I would like to show you, which is about how to correct for the camera deformation. This option is not yet available because it's still under development, but as I'm trying to anticipate a bit the next update, you will probably have it available very soon in the program. To do that again, so I select my video and go to the Prepare Analysis button. So this time we have our two fish. Like always, we have our trajectories and nothing special. But as you can see here, because of the perspective, we have a deformation of the arena. And if I have a trajectories which is making like this movement or this movement, they are supposed to be the same length in real life. But in my computer, I will have the results who tells me that this distance is shorter than this one. And of course, this is a strong bias when we are analyzing our data. So to correct this bias, we have the option of the perspective correction. Just press this button and you will have a new panel with this in the top left corner is one image of your video and this is the corrected image. So for the moment, there is nothing. The first thing you will need to do will be to define points of interest. In my case, I know that this arena was completely circular, so I will just put 4 points of interest in these four locations. And I know that the distance between these 2 points is supposed to be the same distance than between these 2 points. I can now move my points in this schematic view, and it gives me the distance between the different points. I know that between these 2 points I have a 10.7. Well, I know that I should have something about like 10. So I will just put this at 10, and I want the same here. I will just move my points. So I recreate in my schematic view something that's perfect or almost perfect. Of course, I advise you to make it with a bit more time to do it better. I'm just trying to show you a bit fast how to do it. Mhm. And here, I think we have something that's quite good. Validate. And as you can see now, our image has been completely transformed. And now the fence is a real circle, it's not an ellipse anymore. And my trajectories are transformed accordingly. So please be careful when you use this option. Always keep in mind that the transformation is applied after the tracking. So the video is tracked in its original shape, and then the correction is applied on the tracking. Use this little video to show to add some elements of the spatial repartition. I will do it just very fast. And I'm interested in what happened 5 meter. Well, of course, it's too much 2 meter. And add elements, border, all borders. And let's put something like 1 meter. Maybe 1.5. You can see that the arena itself is really circular. Um, and that's it. We saw all the possible operation for the analyses. And now how to run the analysis is very simple. You will just press this little button here, run analysis, select the videos you are interested in. So in my case, it's everyone, and just validate. You have a loading menu that will appear, and it's on. Now we can go back to our folder. So we are in the analysis project. And now we have a new subfolder here, which is called results. And inside these results, you will have a lot of data. The first one is results by individual. Results by individual is a quite simple file. You have one row per individual, and you have a summary of all the trajectories characteristics. So you have the video name, then the arena identification, the name of the individual. In that case, I didn't change the name of my individuals, but if you had set a personal name, it will appear here. The proportion of time each target has been lost. If you smoothed the trajectories, what are the parameters you used for the smoothing? So this here, for instance, is not very interesting in your analysis, but it might be a way to ensure that you use the exact same parameters for all of your videos. Then if you set a particular moving threshold, again, it allows you to be consistent during your tracking and analysis. The proportion of time your individuals were moving, well, obviously, if you don't put a moving threshold, they are moving almost all the time. But you see that in the case of the spider, we've set a moving threshold and the time spent moving is quite lower. You will get the average speed the average speed of your individual, the average speed of the individual, but only considering the moment that this individual is moving. So, of course, again, you have a difference in the case of the spider because we have a moving threshold. But for the individual that are moving 100% of the time, there is no difference between average speed and average speed while moving. The same for the travel distance. We have here also an option that's maybe not yet available on the last version of the program. It will be available soon, so I will keep you updated about that. The meander, it's a representation of how tortuous is the trajectory of the individual. The higher value, the more tortuous it is. The travel distance while moving and meander while moving. So once again, I believe that the meander, for instance, while moving, it's much more interesting than the meander, general meander, because you have here all the noise that are due to the tracking imperfection and to the very, very small movement of either the camera or the individual, while the meander while moving is really the trajectories when the individual is making a real displacement. And you have the exploration values. So if we take a look at our vacuum robot here, we should find back our 80%. So indeed, we have our 80%. The kind of method you used, the default method is the one I called modern, which is making a circle around the individual and no mesh. But if you were using a mesh, you would have the mesh information here, whether rectangular or circular. The exploration area threshold. The exploration aspect parameter is only if you are using a circular mesh, is to indicate which shape you used for your cell. And then these are values related to the inter-individual activities, mean number of neighbor, proportion of time with at least one neighbor, and mean shortest distance to the neighbor. We already saw all this information when working with the end social interactions. Obviously, in that case, you have only values for the videos in which you had more than one neighbor per arena. Because in that case, in the case of the spider, of the fish, and of the robot, they were alone in their arena. We didn't define a threshold for the sheep, sorry, so they never spend time as neighbor because we didn't give them a threshold here. But in the case of the ants, you see the different results, and you can find who is the more sociable, at least in this video, the one who spend the most time close to a partner or not. So that's all for the analysis of individual data. We have also results for the inter-individual data. Well, once again, you only have the videos in which you had more than one individual per arena. And this gives you just the average distance, it's a cumulative distance between all individuals, and the minimum distance we had as a group, and the maximum cumulative distance. And you have these three folders. We have here the spatial folder in which we will see the relationship with the different element we draw in our different arenas. So if you remember, in the case of the visual test, we had an element part A, part B, and two segments. So if I select my element, I will have once again one row per video, the name of the arena, the name of the individual, and the information relative to this particular element of interest. So we can see from this file that this fish was on average of 14 centimeters from the part A, and that it spent about 40% of its time inside this part A. If we look at part B, we have also similar information. Also the segment, which it will give you the number of crosses in one direction and in the other, and the latency to cross the segment for the first time. Was for segment A, you will have something very similar for segment B. We can also check our sheep. So this is the time they spend in the border of the arena. So as you can see, one spent much more time close to the arena than the other. And we have also the distance to the central point that we made for the sheep. So again, we have a big difference between our two sheep, with one sheep spending much less time in the center and being much further from this point. So it looked like one fish. This second fish was probably much more attracted by the border than its conspecific. And finally, you have the general file in which you will have one row per element per arena. So in the case of the fish, well, we had only one fish per arena, so it's also one row per individual. But in the case of the sheep, as you can see, we have one row per element, and this time both individuals are represented in the same row, which gives us information. For instance, if we take a look at the border, you can see that both individuals entered the border arena, and that on average you had more than one individual in the border. If you take a look at what happened in the center of the arena, you also had both individuals who entered at the same time in this arena, but on average they were much less present than in the border. That's all for the spatial information. We also have the inter-individual information. Once again, in this folder, you will have only information about videos who have more than one individual per arena. Let's go for the end because it's the one we used for the social interaction information. And you have four different files. The first one is a summary of all the contact events. For instance, this tells us that individual 7 was in contact with individual 0 during zero point 0.2 seconds at the very beginning of the video, in fact, at 0.04 second after the beginning of the video. So it will give you information about all the contact that happened, their direction, and when they did begin. So this is quite useful, in fact, if you are working with as a kind of survival data analysis. You also have a summary of the contact occurrences. Now, this is a cross table and it will give you information about how much contact you had between your individuals. So, for instance, individual 3 and individual 0 were 9 different times in contact. Individual 9 and 0 were also a lot, well, they made a lot of contact events. But individual 1 and individual 9 were they're never in contact. You have same kind of table, but this time giving you the average distance between your individual and the proportion of time they spent together. So once again, here we have a 0 because as we remember, they were never in contact. That's all for the inter-individual information, and the very last thing you will find is a detailed data folder. In this folder, you will just have a summary of all the tracking of all the individuals. For instance, if I go, let's continue with our fish. So I have one file per individual, and if I open the file, it will give me information about the time of the video, the coordinates of the individual. If we used the smoothing option, it's the smoothed position of the individual. We also have the speed, the instant speed of the individual at this moment, and we will consider whether the individual is moving or not, the distance it traveled between these two frames, and the information relative to the rest of the environment, so the distance to specific part of the arena. But you might also find information of the other individuals. For instance, if I go to take the ants information, in this case, it will give me the distance to each of the other conspecific. So this table is not really analyzed, it's just if you want to make personalized analysis, something a bit more complex, you have all these data that are kept here. And I think we went through every kind of result data you may have with the program. Well, I think this was the last video tutorial for AnimalTA, at least for the moment. Now, if you have still more questions, if there are some points that are unclear, or if you want me to make more videos about different subjects, I invite you to leave a comment under this video. Thank you very much for still being here after all these explanations, and I wish you all a very good day.